Hello everyone, this is Saurabh from Edureka. In today's session, we'll focus on what is Jenkins. So without any further ado, let us move forward and have a look at the agenda for today. First, we'll see why we need continuous integration. What were the problems that industries were facing before continuous integration was introduced? After that, we'll understand what exactly is continuous integration, and we'll see various types of continuous integration tools. Among those continuous integration tools, we'll focus on Jenkins, and we'll also look at Jenkins distributed architecture. Finally, in our hands-on part, we'll prepare a build pipeline using Jenkins, and I'll also tell you how to add Jenkins slaves. So I hope you all are clear with the agenda. Now I'll move forward and we'll see why we need continuous integration. So this is the process before continuous integration. Over here, as you can see, that there's a group of developers who are making changes to the source code that is present in the source code repository. This repository can be a Git repository, subversion repository, etc. And when the entire source code of the application is written, it will be built by tools like Ant, Maven, etc. And after that, that built application will be deployed onto the test server for testing. If there's any bug in the code, developers are notified with the help of the feedback loop, as you can see it on their screen. And if there are no bugs, then the application is deployed onto the production server for release. I know you must be thinking that what is the problem with this process? This process looks fine. As you first write the code, then you build it, then you test it, and finally you deploy it. But let us look at the flaws that were there in this process one by one. So this is the first problem, guys. As you can see that there is a developer who is waiting for a long time in order to get the test results. As first, the entire source code of the application will be built, and then only it will be deployed onto the test server for testing. It takes a lot of time. So developers have to wait for a long time in order to get the test results. The second problem is, since the entire source code of the application is first built and then it is tested, so if there's any bug in the code, developers have to go through the entire source code of the application. As you can see that there is a frustrated developer because he has written a code for an application which was built successfully, but in testing there were certain bugs in that. So he has to check the entire source code of the application in order to remove that bug, which takes a lot of time. So basically locating and fixing of bugs was very time consuming. So I hope we are clear with the two problems that we have just discussed. Kindly give me a quick confirmation so that I can move forward. Or if you have any doubts, please write it down in your chat box. I'll be happy to help you. Any doubts, guys? So shall I move forward? Alright, thanks for the confirmation. Now we'll move forward and we'll see two more problems that were there before continuous integration. So the third problem was software delivery process was slow. Developers were actually wasting a lot of time in locating and fixing of bugs instead of building new applications. As we just saw that locating and fixing of bugs was a very time consuming task, due to which developers were not able to focus on building new applications. You can relate that to the diagram which is present in front of your screen. As we all waste a lot of time in watching TV, doing social media, similarly developers were also wasting a lot of time in fixing bugs. Alright, so let us have a look at the fourth problem, that is continuous feedback. Continuous feedback related to things like build failures, test status, etc. was not present, due to which the developers were unaware of how their application is doing. So we have a question, guys. It is from Anusha. She's asking, the process that you showed before continuous integration, there was a feedback loop present. Very good question, Anusha. So what I'll do, I'll go back to that particular diagram and I'll try to explain you from there. So Anusha, the feedback loop that you're talking about is here. When the entire source code of the application is built and tested, then only the developers are notified about the bugs in the code. Alright? When we talk about continuous feedback, suppose this developer that I'm highlighting makes any commit to the source code that is present in the source code repository. And at that time, the code should be pulled and it should be built. And the moment it is built, the developer should be notified about the build status. And then once it is built successfully, it is then deployed onto the test server for testing. At that time, whatever the test status is, the developer should be notified about it. Similarly, if this developer makes any commit to the source code, at that time the code should be pulled, it should be built, and the build status should be notified to the developers. After that, it should be deployed onto the test server for testing, and the test results should also be given to the developers. I suppose you have got the difference, Anusha, between the continuous feedback and feedback. Yeah, I'll summarize it once again. So what happens when we talk about feedback? Feedback is present. As you can see, first the entire source code of the application will be written, it will be built, and it will be tested, and then only the developers will be notified about the bugs if there are any. When we talk about continuous feedback, suppose the developer that I'm highlighting with my cursor makes any commit in the source code that is present in the source code repository. Alright, so at that time the code should be pulled, it should be built, the developer should be notified about the build results. Similarly, it should be deployed onto the test server for testing, and the developer should also be notified about the test results. Similarly, if the second developer makes any commit to the source code, at that time the code should be pulled, it should be built, developer should be notified about the build results, and after that the build application should be deployed onto the test server for testing, and the developer should be notified about the test results as well. So I hope we all are clear what is the difference between continuous feedback and feedback. So in continuous feedback, you're getting the feedback on the run. Alright. Thanks for the confirmation, Anusha. So we'll move forward and we'll see how exactly continuous integration addresses these problems. Let us see how exactly continuous integration is resolving the issues that we have discussed. So what happens here, there are multiple developers. So if any one of them makes any commit to the source code that is present in the source code repository, the code will be pulled, it will be built, tested and deployed. So what advantage we get here? So first of all, any commit that is made to the source code is built and tested, due to which if there is any bug in the code, developers actually know where the bug is present or which commit has caused that error. So they don't need to go through the entire source code of the application. They just need to check that particular commit which has introduced the bug. Alright, so in that way, locating and fixing of bugs becomes very easy. Apart from that, the first problem that we saw, the developers have to wait for a long time in order to get the test result. Here, every commit made to the source code is tested. So they don't need to wait for a long time in order to get the test results. So when we talk about the third problem, that was software delivery process was slow, is completely removed with this process. Developers are not actually focusing on locating and fixing of bugs, because that won't take a lot of time as we just discussed. Instead of that, they're focusing on building new applications. Now our fourth problem was continuous feedback was not present. But over here, as you can see on the run, developers are getting the feedback about the build status, test results, etc. Developers are continuously notified about how their application is doing. So I hope we are clear with this. Any questions, any doubts, please write it down in the chat box. Guys, I wanted to add this thing. Let us make this session interactive. Alright, you won't even enjoy it if it's a one-way conversation. So whatever doubts, whatever questions you have, please write it down in the chat box and I'll be very happy to help you. And if you have no questions, just give me a confirmation so that I can move forward. Okay, so Quinn says cool. Anisha says no doubts. Anusha says no doubts. Jessica says please move forward. Alright. Thanks for your confirmation, guys. So I'll move forward. Now I'll compare the two scenarios, that is before continuous integration and after continuous integration. Now over here what you can see is before continuous integration, as we just saw, first the source code of the application will be built, the entire source code, then only it will be tested. But when we talk about after continuous integration, every commit, whatever change you made in the source code, whatever change, a minute change as well, you commit it to the source code, that time only the code will be pulled, it will be built and then it will be tested. Developers have to wait for a long time in order to get the test results, as we just saw, because the entire source code will be first built and then it will be deployed onto the test server. But when we talk about continuous integration, the test result of every commit will be given to the developers. And when we talk about feedback, there was no feedback that was present earlier, but in continuous integration, feedback is present. For every commit you made to the source code, you'll be provided with the relevant result. Alright? So now let us move forward and we'll see what exactly is continuous integration. Now in continuous integration process, developers are required to make frequent commits to the source code. They have to frequently make changes in the source code, and because of that, any change made in the source code will be pulled by the continuous integration server. It will be pulled by the continuous integration server, and then that code will be built, or you can say it will be compiled. Alright. Now depending on the continuous integration tool that you are using, or depending on the need of your organization, it will also be deployed onto the test server for testing. And once testing is done, it will also be deployed onto the production server for release. And developers are continuously getting the feedback about their application on the run. So I hope I'm clear with this particular process. Kindly give me a quick confirmation so that I can move forward. Any questions, any queries, guys, please write it down in the chat box. Okay, so Anusha says no questions. Bennett says no questions. Quinn, no doubts. Alright, thanks for your confirmation, guys. So we'll see the importance of continuous integration with the help of a case study of Nokia. So Nokia adopted a process called nightly build. Nightly build can be considered as a predecessor to continuous integration. Let me tell you why. Alright. So over here, as you can see, that there are developers who are committing changes to the source code that is present in a shared repository. Alright. And then what happens in the night, there's a build server. This build server will poll the shared repository for changes, and then it will pull that code and prepare a build. Alright. So in that way, whatever commits are made throughout the day are compiled in the night. So obviously this process is better than writing the entire source code of the application and then compiling it. But again, since if there is any bug in the code, developers have to check all the commits that have been made throughout the day. So it is not the ideal way of doing things because you are again wasting a lot of time in locating and fixing of bugs. All right. So I want answers from you all guys. What can be the solution to this problem? How can Nokia address this particular problem? Since we have seen what exactly continuous integration is and why we need. So you can answer this question, guys. Come on. All right. So Jessica says a build should be triggered for every commit. That is absolutely correct. Bennett says continuous integration. So does Ajay. Alright, let me tell you guys, you all are correct. Now, without wasting any time, I'll move forward and I'll show you how Nokia solved this problem. So Nokia adopted continuous integration as a solution, in which what happens, developers commit changes to the source code in a shared repository, alright, and then what happens is a continuous integration server. This continuous integration server polls the repository for changes if it finds that there is any change made in the source code, and it will pull the code and compile it. So what is happening? The moment you commit a change in the source code, continuous integration server will pull that and prepare a build. So if there's any bug in the code, developers know which commit is causing that error, alright? So they can just go through that particular commit in order to fix the bug. So in this way, locating and fixing of bugs was very easy. But we saw that in nightly builds, if there is any bug, they have to check all the commits that have been made throughout the day. So with the help of continuous integration, they know which commit is causing that error. So locating and fixing of bugs didn't take a lot of time. All right. So any questions, any doubts still here, guys? Any questions? All right. So we have no questions. So shall I move forward? Okay. Before I move forward, let me give you a quick recap of what we have discussed till now. First, we saw why we need continuous integration. What were the problems that industries were facing before continuous integration was introduced? After that, we saw how continuous integration addresses those problems, and we understood what exactly continuous integration is. And then in order to understand the importance of continuous integration, we saw case study of Nokia, in which they shifted from nightly build to continuous integration. All right, so shall I move forward? Kindly give me a quick confirmation. Jessica says yes. Bennett says yes. Ajay says cool. All right, guys. So we'll move forward and we'll see various continuous integration tools available in the market. These are the four most widely used continuous integration tools. First is Jenkins, on which we'll focus in today's session. Then BuildBot, Travis, and Bamboo. All right. And let us move forward and see what exactly Jenkins is. So Jenkins is a continuous integration tool. It is an open source tool and it is written in Java. How it achieves continuous integration? It does that with the help of plugins. Jenkins have well over 1,000 plugins. And that is the major reason why we are focusing on Jenkins. Let me tell you guys, it is the most widely accepted tool for continuous integration because of its flexibility and the amount of plugins that it supports. So as you can see from the diagram itself, that it is supporting various development, deployment, testing technologies. For example, Git, Maven, Selenium, Puppet, Ansible, Nagios. All right. So if you want to integrate a particular tool, you need to make sure that plugin for that tool is installed in your Jenkins. Now for better understanding of Jenkins, let me show you the Jenkins dashboard. I've installed Jenkins in my Ubuntu box. So if you want to learn how to install Jenkins, you can refer the Jenkins installation video. So this is the Jenkins dashboard, guys. As you can see that there are currently no jobs. Because of that, this section is empty. Otherwise, it will give you the status of all your build jobs over here. Now, when you click on new item, you can actually start a new project all over from the scratch. All right. So any questions still here, guys? Any queries you have regarding Jenkins? All right. So we have a question from Ajay. He's asking, what is the difference between Hudson and Jenkins? Ajay, let me tell you this thing, that there is no difference between Hudson and Jenkins. Hudson was only the earlier name of Jenkins. All right. So there's no difference between Hudson and Jenkins. Okay, so we have one more question. It is from Quinn. Quinn is asking, so you've talked about plugins. So do we need to install those plugins or it will come automatically with Jenkins? So what happens, Quinn, when you are installing Jenkins, it will give you two options. First is install relevant plugins, in which there are certain set of plugins which are there and that will be installed. And on the right hand side, there is an option called select the plugins. So over there, you can go and select the plugins that you want to install. And once you have installed Jenkins, then also if you need a plugin, you can actually install that. I'll tell you how to do that later in the session. I hope this answers your question. All right. Thank you, Quinn, for your confirmation. Now let us go back to our slides. Let us move forward and see what are the various categories of plugins. As I've told you earlier as well, that Jenkins achieves continuous integration with the help of plugins. Alright, and Jenkins supports well over 1,000 plugins, and that is a major reason why Jenkins is so popular nowadays. So the plugin categorization is there on your screen. There are certain plugins for testing like JUnit, Selenium, etc. When we talk about reports, we have multiple plugins, for example, HTML Publisher. For notification also, we have many plugins, and I've written one of them, that is Jenkins Build Notification plugin. When we talk about deployment, we have plugins like Deploy plugin. When we talk about compile, we have plugins like Maven and etc. Alright, so let us move forward and see how to actually install a plugin on the same Ubuntu box where my Jenkins is installed. So over here, in order to install Jenkins, what you need to do is, you need to click on Manage Jenkins option. And over here, as you can see, that there's an option called Manage Plugins. Just click over there. As you can see, that it has certain updates for the existing plugins which I have already installed. Alright, then there's an option called Installed, where you'll get the list of plugins that are there in your system. Alright, and at the same time, there's an option called Available. It will give you all the plugins that are available with Jenkins. Alright, so now what I'll do, I'll go ahead and install a plugin that is called HTML Publisher. So it's very easy. What you need to do is just type the name of the plugin. Here it is, HTML Publisher plugin. Just click over there and install without restart. So it is now installing that plugin. We need to wait for some time. So it has now successfully installed. Now let us go back to our Jenkins dashboard. So we have understood what exactly Jenkins is, and we have seen various Jenkins plugins as well. So now is the time to understand Jenkins with an example. We'll see a general workflow, how Jenkins can be used. Alright, so let us go back to our slides. So now, as I've told you earlier as well, we'll see a Jenkins example. So let us move forward. So over here, what is happening? Developers are committing changes to the source code, and that source code is present in a shared repository. It can be a Git repository, Subversion repository, or any other repository. Alright, now let us move forward and see what happens now. Now over here, what is happening? There's a Jenkins server. It is actually polling the source code repository at regular intervals to see if any developer has made any commit to the source code. If there is a change in the source code, it will pull the code and it will prepare a build. And at the same time, developers will be notified about the build results. Now let us execute this practically. Alright, so I'll again go back to my Jenkins dashboard, which is there in my Ubuntu box. Over here, what I'm going to do is, I'm going to create a new item. Alright, basically a new project. Now over here, I'll give a suitable name to my project. You can use any name that you want. I'll just write compile. And now I'll click on freestyle project. The reason for doing that is, freestyle project is the most configurable and the flexible option. It is easier to set up as well. And at the same time, many of the options that we configure here are present in other build jobs as well. Move forward with freestyle project and I'll click on OK. Now over here, what I'll do, I'll go to the source code management tab, and it will ask you for what type of source code management you want. I'll click on Git, and over here you need to type your repository URL. In my case, it is https github.com, your username / the name of your repository, and finally .git. Alright, now in the build option, you have multiple options. Alright, so what I'll do, I'll click on invoke top level Maven targets. Now over here, let me tell you guys that Maven has a build lifecycle, and that build lifecycle is made up of multiple build phases. Typically, the sequence for build phase will be, first you validate the code, then you compile it, then you test it, then you perform unit test by using suitable unit testing framework, then you package your code in a distributable format like jars, then you verify it, and you can actually install any package that you want with the help of install build phase, and then you can deploy it in the production environment for release. So I hope you have understood the Maven build lifecycle. So in the goals tab, so what I need to do is, I need to compile the code that is present in the GitHub account. So for that, in the goals tab, I need to write compile. So this will trigger the compile build phase of Maven. Now that's it guys, that's it. Just click on apply and save. Now on the left hand side, there's an option called build now to trigger the build. Just click over there and you will be able to see that the build is starting. In order to see the console output, you can click on that build and you'll see the console output. So it has validated the GitHub account and it is now starting to compile that code which is there in the GitHub account. So we have successfully compiled the code that was present in the GitHub account. Now let us go back to the Jenkins dashboard. Now in this Jenkins dashboard, you can see that my project is displayed over here. And as you can see, the blue color of the ball indicates that it has been successfully executed. All right. Now let us go back to the slides. Now let us move forward and see what happens once you have compiled your code. Now the code that you have compiled, you need to test it. All right. So what Jenkins will do, it will deploy the code onto the test server for testing. And at the same time, developers will be notified about the test results as well. So let us again execute this practically. I'll go back to my Ubuntu box again. So in the GitHub repository, the test cases are already defined. All right. So we are going to analyze those test cases with the help of Maven. So let me tell you how to do it. We'll again go and click on new item. And over here we'll give any suitable name to our project. I'll just type test. And I'll again use freestyle project for the reason that I've told you earlier. Click on OK. And in the source code management tab, now before applying unit testing on the code that I've compiled, I need to first review it. With the help of PMD plugin, I'll do that. So for that, I'll again click on new item. And over here, I need to type the name of the project. So I'll just type it as code_review. Freestyle project, click OK. Now in the source code management tab, I'll again choose Git and give my repository URL, https github.com/username/name of the repository .git. All right. Now scroll down. Now in the build tab, I'm going to click over there. And again, I'll click on invoke top level Maven targets. Now in order to review the code, I'm going to use the matrix profile of Maven. So how to do that? Let me tell you. You need to type here -p matrix pmd::pmd. All right. And this will actually produce a PMD report that contains all the warnings and errors. Now in the post build action tab, I click on publish PMD analysis result. That's all. Click on apply and save. Now finally click on build now and let us see the console output. So it has now pulled the code from the GitHub account and performing the code review. So it has successfully reviewed the code. Now let us go back to the project. Over here you can see an option called PMD warnings. Just click over there and it will display all the warnings that are there present in your code. So this is the PMD analysis report. Over here as you can see that there are total 11 warnings and you can find the details here as well, like package you have, then you have categories, then the types of warnings which are there, like for example empty catch blocks, empty finally block. Now you have one more tab called warnings. Over there you can find where the warning is present, the file name, package. All right. Then you can find all the details. In the details tab, it will actually tell you where the warning is present in your code. All right. Now let us go back to the Jenkins dashboard and now we'll perform unit test on the code that we have compiled. For that, again, I'll click on new item and I'll give a name to this project. I'll just type test and I'll click on freestyle project. OK. Now in the source code management tab, I'll click on Git. Now over here, I'll type the repository URL, https github.com/username/name of the repository .git. And in the build option, I'll click on again invoke top level Maven targets. Now over here, as I've told you earlier as well, that Maven build lifecycle has multiple build phases. Like first it will validate the code, compile, then test it, package, then it will verify, then it will install if certain packages are required, and then finally it will deploy it. All right. So one of the phase is actually testing, that performs unit testing using the suitable unit testing framework. The test cases are already defined in my GitHub account. So to analyze that test case in the goal section, I need to write test. All right. And it will invoke the test phase of the Maven build lifecycle. All right. So just click on apply and save. Finally, click on build now. To see the console output, click here. Now in the source code management tab, I'll select Git. All right. Over here, again, I need to type my repository URL. That is https github.com/username/repository name.git. And now in the build tab, I'll select invoke top level Maven targets. And over here, as I've told you earlier as well, that the Maven build lifecycle has multiple phases, all right, and one of that phase is a unit test. So in order to invoke that unit test, what I need to do is in the goals tab, I need to write test, and it will invoke the test build phase of the Maven build lifecycle. All right. So the moment I write test here and I'll build it, it will actually analyze the test cases that are present in the GitHub account. So let us write test and apply and save. Finally, click on build now. And in order to see the console output, click here. So it has pulled the code from the GitHub account and now it is performing unit test. So we have successfully performed testing on that code. Now I'll go back to my Jenkins dashboard. Over here, as you can see that all the 3 build jobs that I've executed are successful, which is indicated with the help of blue colored ball. All right. Now let us go back to our slides. So we have successfully performed a unit test on the test cases that were there on the GitHub account. Now we'll move forward and see what happens after that. Now finally, you can deploy that build application onto the production environment for release. But when you have one single Jenkins server, there are multiple disadvantages. So let us discuss that one by one. So we'll move forward and we'll see what are the disadvantages of using one single Jenkins server. Now what I'll do, I'll go back to my Jenkins dashboard and I'll show you how to create a build pipeline. All right. So for that, I'll move to my Ubuntu box once again. Now over here, you can see that there's an option of plus. Okay, just click over there. Now over here, click on build pipeline view. Whatever name you want, you can give. I'll just give it as Edureka underscore pipeline and click on OK. Now over here, what you can do, you can give some certain description about your build pipeline. All right. And there are multiple options that you can just have a look. And over here, there's an option called select initial job. So I want compiled to be my first job. And there are display options over here, number of display builds that you want. I'll just keep it as 5. Now the row headers that you want, column headers. So you can just have a look at all these options and you can play around with them. Just for the introductory example, let us keep it this way. Now finally click on apply and OK. Now currently you can see that there is only one job that is compiled. So what I'll do, I'll add more jobs to this pipeline. For that, I'll go back to my Jenkins dashboard and over here, I'll add code review as well. So for that, I'll go to configure. And in this build triggers tab, what I'll do, I'll click on build after other projects are built. So whatever project that you want to execute before code review, just type that. So I want compile. Yeah, click on compile. And over here, you can see that there are multiple options like trigger only if build is stable, trigger even if the build is unstable, trigger even if the build fails. So I'll just click on a trigger even if the build fails. All right. Finally, click on apply and save. Similarly, if I want to add my test job as well to the pipeline, I can click on configure. And again, the build triggers tab, I'll click on build after other projects are built. So over here, type the project that you want to execute before this particular project. In our case, it is code review. So let us click over there, trigger even if the build fails, apply and save. Now let us go back to the dashboard and see how our pipeline looks like. So this is our pipeline. Okay. So when we click on run, let us see what happens. First, it will compile the code from the GitHub account. That is, it will pull the code and it will compile it. So now this compile is done. All right. Now it will review the code. So the code review has started. In order to see the log, you can click on console. It will give you the console output. Now once code review is done, it will start testing. It will perform unit test. All right. So code has been successfully reviewed with the, as you can see, the color has become green. Now the testing has started. It will perform unit test on the test cases that are there in the GitHub account. So we have successfully executed the 3 build jobs, that is compile the code, then review it and then perform testing. All right. And this is the build pipeline, guys. So let us go back to the Jenkins dashboard and we'll go back to our slides now. So now we have successfully performed unit test on the test cases that are present in the GitHub account. All right. Now let us move forward and see what else you can do with Jenkins. Now the application that we have tested, that can also be deployed onto the production server for release as well. All right. So now let us move forward and see what are the disadvantages of this one single Jenkins server. So there are 2 major disadvantages of using one single Jenkins server. First is you might require different environments for your builds and test jobs. All right. So at that time, one single Jenkins server cannot serve our purpose. And the second major disadvantage is Suppose you have heavier projects to build on regular basis. So at that time, one single Jenkins server cannot simply handle the load. Let us understand this with an example. Suppose if you need to run web tests using Internet Explorer. So at that time, you need a Windows machine. But your other build jobs might require a Linux box. So you can't use one single Jenkins server. Alright. So let us move forward and see what is actually the solution to this problem. The solution to this problem is Jenkins distributed architecture. So the Jenkins distributed architecture consists of a Jenkins master and multiple Jenkins slaves. So this Jenkins master is actually used for scheduling build jobs. It also dispatches builds to the slaves for actual execution. Alright. It also monitors the slave that is possibly taking them online and offline as required. And it also records and presents the build results. And you can directly execute a build job on master instance as well. Now when we talk about Jenkins slaves, these slaves are nothing but the Java executable that are present on remote machines. Alright. So these slaves basically here's a request from the Jenkins master, or you can say they perform the jobs as told by the Jenkins master. They operate on variety of operating system. So you can configure Jenkins in order to execute a particular type of build job on a particular Jenkins slave or on a particular type of Jenkins slave, or you can actually let Jenkins pick the next available Jenkins slave. Alright. Now I'll go back again to my Ubuntu box and I'll show you practically how to add Jenkins slaves. Now over here, as you can see that there is an option called Manage Jenkins. Just click over there, and when you scroll down you'll see an option called Manage Nodes. And on the left hand side there is an option called New Node. Just click over there, click on Permanent Agent, give a name to your slave. I'll just give it as slave_1. Click on OK. Over here you need to write the remote root directories. So I'll keep it as /home/Edureka, and labels are not mandatory. Still, if you want, you can use that. And launch method, I want it to be launch slave agents via SSH. Alright, over here you need to give the IP address of your host. So let me show you the IP address of my host. This is my Jenkins slave, which I'll be using like Jenkins slave. So this is the machine that I'll be using as Jenkins slave. In order to check the IP address, I'll type ifconfig, and this is the IP address of that machine. Just copy it. Now I'll go back to my Jenkins master, and in the host tab I'll just paste that IP address. And over here you can add the credentials. To do that, just click on add, and over here you can give the username. I'll give it as root, password. That's all. Just click on add, and over here select it. Now finally save it. Now it is currently adding the slave. In order to see the logs, you can click on that slave again. Now it has successfully added that particular slave. Now what I'll do, I'll show you the logs. For that I'll click on slave, and on the left hand side you will notice an option called log. Just click over there and it'll give you the output. So as you can see, agent has successfully connected and it is online right now. Now what I'll do, I'll go to my Jenkins slave and I'll show you in /home/Edureka that it is added. Let me first clear my terminal. Now what I'll do, I'll show you the contents of /home/Edureka. As you can see that we have successfully added slave.jar. That means we have successfully added Jenkins slave to our Jenkins master. Thank you for attending today's session. Thank you and have a great day.